Okay, so we're back here. Today we're in section 6.4, truth tables for arguments. So we're going to get a little bit more practice constructing truth tables and using truth tables to determine whether an argument is valid or invalid. So we've already looked at a couple different uses of truth tables in 6.3, how to classify and compare statements. Here we're going to use truth tables for arguments to check to see whether they're valid or invalid. So I have a simple argument for you here on the screen. If we look how it's arranged, premise 1, P horseshoe Q, premise 2, Q horseshoe R, and our conclusion signified with the double slash P horseshoe R. Okay, so let me just label that for you. We have premise 1, premise 2, and our conclusion. Okay, so you know from the textbook that the first step in using truth tables for arguments is to determine how many different lines of truth tables we will have. Okay, now that's going to be determined by the number of different letters we have up here. So in this case we have P, we have Q, and we have R. So 3 different letters, which tells us we need 8 lines for the truth table. So this one will be a little bit longer of a truth table here, as we have to write up 8 different lines. So let's go ahead and do that. I'll number these lines because it gets a little sloppy on the board, a little bit easier on white paper. Let's do that here. Okay, so 8 lines total. So our first 4 lines will be true, our next 4 lines will be false, and so on. Okay, so select our first letter P. We're going to go 4 trues. So true, 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 and then 4 falses. Okay, so we have 4 trues, 4 falses. We go to our next letter, and we just divide that in half. So if we did 4 trues, 4 falses, under Q, we're going to go 2 trues, 2 falses, 2 trues, 2 falses, and so on. So true, true, false, false, true, true, false, false. Okay, so premise 1 is done. Premise 2, we have Q here. Now this is where we have to be careful because we want to put the same truth values under our first Q, under the second Q as well. If we don't do that, our truth table will be distorted, we'll get incorrect results, and we'll probably end up getting it wrong. So we've got to be real careful on that. So same truth values, true, true, false, false, true, true, and false, false. Okay. Finally, we come to R here. So under our Q, our second letter, we did 2 trues, 2 falses. So we just divide that in half again. Under R, we'll get true, false, all the way down. Okay. So remember, that's somewhat review for us. That's in our textbook in 6.3. You can review that if you still have questions. Okay, so premise 2 is done. Our conclusion, P horseshoe R. We've already inputted truth values for our P, so we just want to put those same truth values in. R, same truth values. Okay, so it looks like we're done here. I will go ahead and number these lines for you. Okay, so there we go. A little bit easier to keep track of. One of the things you'll notice about truth tables is that they're very mechanical. So we're always going to set them up the same way. We're going to evaluate arguments the same way every time. Once you get them down, you'll quickly become a master of truth tables. Okay, so let's start with our premise 1 here. So we have a horseshoe statement. So P horseshoe Q, which is a conditional statement. So we're saying if P, then Q. P and Q can stand for any statement. If it's sunny, then the park is open. Just any statement like that. Okay, so line 1 here is saying that P is true and Q is true. So if P is true and Q is true, we know our overall truth value will be true. Okay. Line 2, same truth values. P is true, Q is true. We know that our truth value would be true. So notice what we're doing here. We're just building off of what we covered in 6.2 when we looked at truth functions. Right? So we know the truth values for a conditional statement. The only time it's false is when the antecedent is true and the consequent is false. Apart from that, it's always true. So you can actually work through these pretty quickly once you know the truth values for our conditional statement here. Okay, so next we see line 3. Antecedent P is true, consequent Q is false. We know it's going to be false. Same truth values here. And once we get to 5, 6, 7, and 8, we see that our P statement is true, or if false rather. Our P statement is false. So we know that if the antecedent's false, the overall statement is true. And we covered that in 6.2. So we can go through these real quickly. Just like so there. Okay, then we can go through, highlight this. I like using different colors on the screen, a little bit easier to look at there. Okay, so premise 2, same thing, conditional statement. So we have a true, false, true, 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 false, true, and a true. Let's go through, highlight that. Our conclusion here, another conditional statement. We should be familiar with those by now. True, false, true, false, and true, 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 true. Okay, so we've properly used truth tables here to compute the truth value of each of our 2 premises and the conclusion. So now when we're evaluating for arguments, we're going through and we're looking for one line in which our premises are true and the conclusion false. Because that tells us here with all 8 possibilities, all 8 different scenarios, that if we have one line where the premises are true and the conclusion false, then it's possible that the premises are true and the conclusion is false, which is a definition for an invalid deductive argument. Okay, so when we're evaluating these, just focus on the conclusion. Right, so we have a false here in line number 2, but notice our first premise is true, second premise is false, conclusion false, so that passes the test. Right, we would only circle this if the conclusion is false and our 2 premises are both true. As long as one's false, that's okay. Looks like we go down to line 4 here. We have false for the conclusion. Premise 2 is true. Premise 1 is false. So again, that doesn't pass the invalid test. Right? It's only invalid if both premises are true and the conclusion is false. So we look through this argument here. We don't see that to be the case in any of the 8 possibilities. So we conclude that this argument is valid. Okay. So hopefully that helps you out on this one. A little bit longer of a truth table, 8 lines. But we're going to follow the same process we use for shorter truth tables. Just set it up, go through, input the truth values, and then look at the conclusion. Look for a line where the premises are all true and the conclusion is false. If you find one, the overall argument is invalid. If you don't find one, like in this case here, the argument would be valid. Okay, let me know if you have any questions. Good luck. Keep up the good work.